Okay, 8 for HL, 10 for SL. So let T be the random variable, the score of the game. Complete the table. So basically the game is 2 dice are rolled, and the score is the highest one that comes up. So basically if you roll a 2 and a 5, the score is a 5. If you roll a 3 and a 4, the score is a 4. Complete the table. So this tells us the probability that the score is a 1. Well, the only way, and it shows you here a nice few dots here, this is if you get a 1 and a 1, a 1 and a 2, 1 and a 3, 1 and a 4, 2 and a 1, etc. The only way that the 1 can be your highest score is if you get a 1 and a 1. So there's only one of these. And how many outcomes are there? Well, there's 36. So this has to be 1 out of 36. How can you get a highest score of a 2? Well, you can get a 2 and a 1, 1 and a 2. So this one, or a 2 and a 2. Because remember, you're throwing 2 dice. So there's actually 3 of those, so that gives us 3 out of 36. What about a 3? Well, you can get a 3 and a 1, a 3 and a 2. Sorry, a 3, what am I doing? I can get a 3 and a 1, a 3 and a 2, a 3 and a 3, or a 2 and a 3, and a 1 and a 3. So the 1, 2, 3, 4, 5. So there's 5 of them. 5 out of 36. Now I often like to just kind of go to the end here, guys, because these ones are easier. So a 6 is 1 out of 36. It's just this one. You need to get 2. You need to get. No, sorry, I'm wrong. What am I talking about? It could be a 6 and a 1, a 6 and a 2, a 6 and a 3. So it's actually, well, it's actually all of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's actually 11 out of 36. And then this guy is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 36. You can actually see a nice pattern developing here. This guy is 1, 2, 3, 4, 5, 6, 7. 7 out of 36. Now these should all add up to 36 out of 36. That's 4, 9, 16. 16 plus 9 is 25. Plus 11 is 36. So it's 36 out of 36, which I was expecting. Okay, that's part A. Part B. Find the probability that a player scores at least 3 in a game. So if he's going to score at least 3, then that's the same as his highest score being the 3 or 4 or 5 or 6. So it's basically this plus this plus this plus this. So probability at least 3 is any of these except these 4 out of 36. So that would be 32 out of 36. So that's B part I should have said. B part I, and then this is B part II. A player scores 6 given that they scored at least 3. So probability that it's a player scores 6, so 6 given at least 3. Okay, 2 ways to do this. I'm just going to go with my kind of the first way that always works. That's the formula. So that's the probability of 6 and at least 3 divided by at least 3. Now, how many ways can he get a 6 and he has at least a 3? Well, that's just the same as the probability that he gets a 6, because he has to get a 6 and he has to be at least 3. Well, that's the exact same as the probability of getting a 6, because if he gets a 6, he's at least 3. So that's 11 out of 36. And then we divide all that by the probability of at least 3, which is 32 out of 36. And this is the same as flip and multiply if you want, but those 36s are going to cancel and you're left with 11 out of 32. Another kind of more maybe intuitive way to do it, I like to show this way because this way always works, the formula. But if you want to think of it, another kind of maybe easier way to think of it is, given they score at least 3, if they score at least 3, it's basically at least 3 is basically all of these. It's saying given now one of these has happened, so there's now only 32 outcomes available, and out of these 32 outcomes, how many have a 6 in it? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 11 out of these 32. So that's kind of another way to think of it. Okay, and finally, part C, find the expected score. So the expected value of t is, they always ask this question, guys, in these discrete random variable questions in one form or another. It's this times this plus 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 this times this. That is a formula in the formula booklet as well, but hopefully you know it. So it's 1 times 1 over 36 plus 2 times 3 over 36 plus, you can put these in brackets if you want, 3 times 5 over 36 plus 4 times 7 over 36 plus 5 times 9 over 36, plus 5 times 9 over 36 plus 6 times 11 over 36. And this is equal to, you can use your calculator here, guys, because this is going to get too tricky for me. So it's basically going to be 1 times 1, which is 1, plus 2 times 3 is 6, plus 3 times 5 is 15, plus 4 times 7 is 28, plus 5 times 9 is 45, plus 6 times 11 is 66, 161. So it's 161 over 36, which is that simplified. So it's 161 over 36, 161 over 36. That's fine, to be honest. If for any reason you prefer to give it as a decimal, you can just do that, and you get 4.47222. 4.47222. If you really want to give it to 3 significant figures, 4.47. So in this game, the expected value, or the mean, basically if you play this game 1,000,000 times, on average you would get 4.47. That's what it means. Okay, that's question 8 and 10.